Welcome to the next session on Introduction to AI and ML using Python.
So I hope all the puzzle. Maybe if your answer is correct, then you can explain this puzzle. Could you please explain your puzzle?
Yeah, so for this, it was not a direct or any method to solve it. What I did was there was a 10-digit number.
Okay.
So initially, I put 9 on the first place and put every other number as 0.
Right.
And then I checked. So since 9 is coming in the first place, the last cannot be 0.
Right.
So the last I would cut 0 and put 1. So it was an iterative process. After some time, you get a hang of it. And I reached this number.
Right. I really appreciate it. The puzzle was we want to come up with a 10-digit number such that first digit tells number of zeros in this number. Second digit tells number of ones in this number. This third digit tells number of twos in this number and so on. And the last digit tells number of nines in this number. So it's pretty clear that, let's say that there is no right or wrong method for this puzzle, but the approach, what he has suggested is amazing. Start with 9 on the units digit, assuming that the number of zeros are 9. That means this all has to be 0. And now if you notice, it is correctly counting all the number of zeros in this number, which are 9, but there is one flaw in this, that here it is 9. So the last digit tells the count of number of nines, right? So it has to be ideally 1. And then if it is ideally 1, then it has to be 8. And then if it is 8, then this has to be 1 and this has to be 0. And then if we have 1 here, this number is a number of, it's a count of number of ones, right? So then it has to be 1. And now if it is 1, now there are 2 ones, so it has to be ideally 2. So you're getting my point, right? So you will be stuck within loop under loop and loop. And then you have to keep on trying this, and you will come to know that with 8 you won't get the solution. We have already discussed about 9. For 9 there is no solution. Similarly for 8 also there will not be a solution. Similarly, if you try with 7, you will understand that there is no solution. And then when you come to 6, and then if you go under loop, what do I mean loop under loop? You try to analyze a lot, dig as much as you can with the starting digit as 6, and then you will notice when there is a 6, that means there has to be 6 zeros. And now you can place those 6 zeros anywhere, and then you can try, because 6 number of zeros, so number of zeros are 6, which is correct. Number of ones is 2. As you can see, number of ones are 2. Here number of twos are 1, so number of twos is 1. And then number of 3 is 0, number of 4 0, number of 5s are 0, number of 6 is 1, number of 7s is 0, number of 8s is 0, number of 9s is 0. So I really appreciate, because this is one of the difficult puzzles which I have ever seen in terms of mathematics. We wanted to discuss few things, right? So the first thing which we wanted to discuss was k-fold cross validation. I'm not sure if you guys have come up with the answer. And then second was gamma. I'm not sure why you are not able to come up with the significance of gamma, because if you explore it on Google, you will get the answer for this. I'm not sure if you're not finding time. So let me explain that now. I'm giving you, every time I'm giving you some amount of time so that you can go back and then you can surf on internet and then you can identify the answer by yourself. By that you will learn a lot of things. But never mind. I'm not sure if you guys have found the answer for gamma or not. Please try to come up with the answer by next session. Okay. So let's discuss this k-fold cross validation. Okay. Now let's take a very simple data set which has 10 data points. Okay. Now what are these 10 data points which I am pointing by circles? Are these features or records? So it can have as many features as it can. So these are records. If you draw a data frame or table, these are records, 10 data points. And then there can be multiple features, x1, x2, and so on. But that's not a concern here, because when we are talking about k-fold cross validation with 10 data points, and let's say that I'm choosing two-fold cross validation. When I choose two-fold cross validation, what does it mean? That I have to solve this 2 times. I have to sample this 2 times. What does that mean? That means this would be training in the first set. This would be training and this would be test. Apply your algorithm, solve it, get the solution. And this would be your first fold. The second fold would be, this would be your test. This would be your training. Now solve it, get the solution. But what should be the final solution in this case? So it's very important to understand what is this k-fold cross validation. See, this k-fold cross validation is not kind of algorithm. It's kind of validating. It's like for cross-checking. Okay. It is used for cross-checking. Okay. So for example, let's say that, see, what people generally do is they get, for example, we are using linear regression. Okay. Let's say we are using linear regression. They will find the R square here. They will find the R square here, and they will take the average of that. And that would be the final R square. But that's fine. We got the final average R square value. But what will be the final predicted value? See, you can average out your R square. Similarly, for example, if I'm using logistic regression, you will get the accuracy score from here. In Python, you can use that score function, right? Get the score from confusion matrix, get the score from here, and then you can average it out. Okay. So for averaging your accuracy or evaluation parameter, that should not be a problem. The problem is how to come up with a final prediction. And that was the question. Now let's assume in this case, same thing, 10 data points. I have not given the answer yet. Please hold on for that. Let's assume that I have a 10 data point now. I am using 5-fold cross validation. What does that mean? It has to be divided into 5 groups, right? In first fold, this would be my test, remaining would be train. In second, this would be my test, remaining would be train. Third, these two would be my test, remaining would be train. So here, as you can notice, with 5-fold here, what we are doing it is 80-20% ratio. With 2-fold, we were using 50-50, right? And then in 4th fold and then 5th fold as go on, okay? So far so good. Now there are 2 things for me to discuss. How to finalize the value of k. Again, this value of k is not with knn or k-means, okay? Please do not get confused. We have already discussed about knn and k-means. This is k-fold cross validation, okay? And the second thing which we need to discuss is how to come up with a final prediction. Think in this direction. How would you come up with a final prediction in this scenario? For example, if I want to come up with a final prediction of this point, how would I come up with a final prediction? It was here, it is in test case, test data set. So I am able to find the prediction for this. But in the second fold, it is in train, right? So I have to use the actual values of it, and then I have to build my machine learning model. So in general, what I always tell to my students is k-fold cross validation should not be used for predictions. K-fold cross validation should be used for cross-checking your model. What do I mean by cross-checking your model? For example, let's say that, let's take in this scenario in 5-fold cross validation. Let's say with this sample, I got 70% of accuracy. Let's say you have built the model and you got the accuracy for this using this, okay? First fold. Assume that you are not using anything. Assume that you have already directly built the model and then you got the 70% of the accuracy. And now you want to dig further. When you dig further, you will notice that these 2 points were chosen as test and the remaining were trained. Now, for better understanding, what we should do is we should convert this test from here to here. We should replace our test data set. And then you would notice the accuracy somewhere around 71%. And then you can notice here I am getting the accuracy, say for example with this, say 75% of accuracy. Say here I am getting, say for example, 74% of accuracy. Say here I am getting 77% of accuracy. Now it is just for checking your scores and comparing. This is used for cross validation. Okay, you are validating your model with other folds, whether the model which I have developed by taking this as a test data set has been a right thing or not. For example, if I'm proceeding with this 70% is my final model, and you have already noticed that this is a 77%, which is giving a very high accuracy, then it's pretty straightforward. The final accuracy, what I'm getting here, it is overfitted, right? It is overfitted because in this model, the accuracy what we are getting is around 70%. And let's say in all the cases, your training accuracy is around 80%. Let's say that the training accuracy is around 80%. Now it's giving us a hint that if we are using this model, then what we are getting is overfitted result. Okay, so what does this mean? That the sampling is very important. Okay, so this is where sometimes what happens, say for example, you have a set of data points, say 10 in this case also, I'm just giving examples. Okay, and this remaining 8 points have the same criteria, like 1 and remaining 8, so total 9 points have some characteristics. This point altogether has a different characteristic. So it will be very difficult for machine learning model to predict the right output for this data point. And that's the reason that you might be seeing the accuracy very low. But what if you convert this point itself into training data set? So this all analysis should be done with the help of k-fold cross validation. You should not use this models, all the 5 models for your output. It's not the case. It is just used for analyzing your output. See, I'm not sure people might use it as a final solution, but for me, I always tell this is not a way, this is not an algorithm to predict something. It tells that what different samples have a different characteristic, or it is just used for analyzing your outputs. Okay. So to understand whether the model is overfitted or underfitted, take one more example here. Say I have 10 data points. Okay. Now how to choose this value of k? Now let's say I am choosing the value of k equal to 10. What does this mean? How many data points will a test data set will have? What will be the ratio of training and test data set in this case, guys? 1 and 9. So this would be test in first fold, this would be test in second fold, so on up to this would be the test for 10th fold. Now it's pretty straightforward. When you have very high value of k, you would notice that in the training data set, you will have a lot of data points where you are actually building the model. But then it would be very difficult to generalize this onto this single point. Okay, so what I'm trying to tell here is, higher the value of k, you will have very less data points in your test data set. So by this, what you are trying to do is, you are trying to overfit your model. Okay, that is one thing. Now, can k be very less? Now you have already noticed what happens when k is very less. With 10 data points, if k is equal to 2, you have noticed that test and train will have exactly 50-50%. Right? So is it the right thing to do? Now, this would lead to underfitting of your problem. Okay? So you have to choose the right value of k. Okay? But in general, you should understand why this sample is giving 77% and why the other sample is giving 70%. So you should try to analyze that. That is more important. But yes, you can go ahead with that sample. Okay, so today's session, we will discuss about hierarchical clustering, okay? And then we will do some Python coding for today's session. And today we will be having a lot of time for Python. So we'll basics of Python also today, some more simple examples, some coding challenges, okay? Because hierarchical clustering will not take more time now, as you have already learned what is k-means. I hope you guys have already got the solution for first question, how does the similarity is calculated if the data is categorical in nature? It is something similar to the way we have looked in KNN. You can check that. Okay, so let's start with unsupervised learning, which we have already started in the earlier session. Let's continue with that. So we were discussing about clustering. So in clustering, I told there are different methods of clustering, but we'll be looking for two methods, which is k-means and hierarchical clustering, because these are the two methods which are in general used majority of the times in the organizations. So what happens is, if you remember in k-means, the records or the data points were compared with the centroid and we have calculated the distances, right? Here, the nodes or the data points are compared with each other. Okay. So that to identify the similarities. Okay. Now what happens in this, to explain it in a better way, let's say that you have 10 records again. Okay. Now those are somewhere in space, depending on how many features or what dimensional it is. Say we have only 4 features, so it is a 4-dimensional, right? So let's say that these are the data points in space, assume that. Now what happens in this case, the only difference between k-means and in hierarchical clustering is, in k-means we have calculated the distances from the data points and its corresponding centroid, right? But here, the distances would be calculated from one point to another, from one point to another, and so on. Like, for example, I have 10 records. And if I want to calculate the distance between all the points among each other, okay, every point will have 4 features, okay, x1, x2, x3, x4. Let's say that all the 4 features are numerical, okay, or continuous. Now you know that you can use Euclidean distance formula for calculating the distances. But I have a question before going ahead. It's very important for me to always check your mathematical knowledge here. For example, I have 10 records, then how many times I should be calculating the distance formula? How many times distance formula should be evaluated if I have 10 records? See, I have to calculate the distance between this point to this point, 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 this point to this point. I have to calculate the distances between all the 2 points, right? The distances can be calculated 2 points at one point of time. If you want to calculate the distance, you have to select 2 points, right? And then you have to calculate the distance. I know how did you get the answer 10 into 9? Okay, got it. So ideally when we calculate the distance, say from this point to this point, we should not calculate from this point to this point distance, right? Because we have already calculated that. So for example, let's take in IPL. In IPL, there will be generally 8 teams, right? So if you want to conduct round robin, there will be 8C2 matches. Of course, they play twice with every team, but that's a different story. But if they want everyone to play among themselves in a round robin, that would be 8C2, right? So here also it would be 10C2. So which is 10 into 9 by 2, which is 45. Okay. So this is your right answer. But then yes, it's understood that this should not be repeated. Okay. So we have to calculate the distances, and based on the distances, so this distance, what is this distance doing for us? This is a similarity measure. Similarity measure, this distance formula. And based on the similarity, you would come up with the clusters here. Okay, for example, let's say that these are the 9 data points you have. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. These are the 9 data points which you have. Okay. Now, see, the only advantage of hierarchical clustering is it gives you a better visualization of clusters. Okay. But then there is a disadvantage also. I'll just tell you. So this figure, what you are looking at, it is called as dendrogram. So hierarchical clustering will always be represented by a dendrogram. Okay. So for example, there are 9 data points in the space, and then you calculate the distances from all the data points. Okay. Let's say you have already calculated the distance. Now you have noticed that these 2 points are very near to each other. Okay. So don't compare the distance by looking at this in this space in the horizontal line. Okay. Don't assume that these 2 points are near to each other in space. Okay. These 2 points are near to each other in the space. So if you consider that in the horizontal direction, then you might assume that this point is also very near to these data points. So these are not the location of the data points in the space. These are just, there are 9 data points randomly in the space. These 9 data points are randomly placed in the space. Okay. So I've calculated the distance. I've noticed that the 2 points here are near to each other. Okay. So let's say that those 2 points are near to each other, and then those 2 will form a kind of this 2 point will lead to a single branch now. So now what is this vertical direction is giving you is the distance between these 2 points. This is how the dendrogram is created. Try to understand this. Okay, it's very important. The distance between these 2 points is denoted by these vertical lines in the dendrogram, and then it will place these 2 points next to each other in the dendrogram figure, and then it will check which could be the next point which is very near to this. They will notice, the algorithm will notice that this point is very near to these 2 points. Then it will create a third node, and then it will be calculated from here. Okay, so this point will be joined to this branch, and then distance would be this. Distance would be given by this. If you're not able to understand the distance, that's okay. Don't worry about that. But what I'm trying to tell here is this 2 point can be formed a cluster based on this distance value. But if this is the distance value, maximum distance value which we are looking for, then these 3 points can be formed as a cluster. Similarly, here in the space, these 2 points are very near to each other. And then this is the distance between them. And then there will be third point which will be slightly far away from these 2 points, and that would be also forming a cluster here like this. And similarly, there would be some more 2 points which are very near to each other, and then somewhere like this. And then this is how your dendrogram is formed. Okay, so you're getting my point, right? There will be a third point which might be very near to these 2 points then. So there will be a third point which will be coming and appending to this branch. So that is how the dendrogram has been created. But what is important here is we need to understand how many clusters are we looking for. For example, if I am looking for one cluster, ideally we will not have one cluster, right? Then there is no use of using clustering then. Then I will cut the branch here. Then what happens? All the data points will be in one cluster. Okay. If I cut the branch here, you will have one cluster like this, and the other cluster would be this. All these data points. Now, if I cut the branch somewhere here by this blue line, then can you tell me how many cluster will I have? So when I cut the cluster here with this blue dotted line, can you tell how many clusters I am forming? 4. Just check how many branches we are cutting here. 1, 2, 3, and 4. So there are 4 branches which we are cutting. So there will be 4 clusters. So the first cluster has 3 points, data points. Second cluster has 3 data points. Third cluster has only 1 point. That means this point should be really far. Okay, and that point would not be very near to any other point. So that point would form a separate cluster. Okay. And then there will be these 2 points in this fourth cluster. So in this case, you have to study the data and then you have to decide how many clusters do you need. Okay, you have to decide in hierarchical clustering. But in k-means, you can always come up with an optimal value of k, number of clusters. But that's a disadvantage in hierarchical clustering. And then one more point is, if you notice, for 9 data points, we have so many branches. Assume I have 10,000 data points. Then how many lines you will be seeing on this? It will be very clumsy and it will be really difficult to understand the data points, right? To understand this and to read the data or to read the dendrogram. So it will look really clumsy. So one more disadvantage is of hierarchical clustering is it cannot be properly visualized when you have many data points. So for those cases, we generally go with k-means. Okay, great. And then disadvantage of k-means would be you already know. You won't be able to visualize the data in a better way in k-means. Okay, so that was a thing which I wanted to discuss. But before going ahead, I want to tell you that in hierarchical clustering, there are 2 approaches. Okay, one is agglomerative approach and the other one is divisive approach. Agglomerative approach is a bottom-up approach. Okay, so what happens in this method is each node represents a single cluster at the beginning. Eventually, node starts merging based on their similarity and all the nodes belong to same cluster. So the figure what I'm showing here is kind of agglomerative hierarchical clustering. That means bottom-up approach. That means all the points will initially be each one cluster separately. And then based on the similarity score, they will try to merge. Now this can be one cluster, and then based on this similarity, this is also coming and merging here. So now if you want to cut our branch here, and if for example if you want 4 clusters, then this will form one cluster, right? So that is what bottom up approach means.